Good evening, and a very warm welcome to the audience here and those joining us live via YouTube to the Digital Roads of the Future debate. My name is Ioannis Brilakis, and I'm a professor of the Lengourou Center for Construction Engineering and Technology at the University of Cambridge, and I'm also the academic lead of the Digital Roads of the Future initiative, who is hosting the debate this evening at this historic and very beautiful debating chamber here at the Cambridge Union, at the heart of the city of Cambridge in the United Kingdom. I'm delighted to introduce to you Professor Lord Robert Mair, Emeritus Sir Kirby Lang Professor of Civil Engineering at the University of Cambridge, who is going to chair the debate this evening. Lord Mair was President of the Institution of Civil Engineers from 2017 to 2018, its 200th anniversary year. He's a Fellow of the Royal Academy of Engineering, a Fellow of the Royal Society, and a foreign member of the US National Academy of Engineering. Lord Mair is the founding head of the Cambridge Center for Smart Infrastructure and Construction, CSIC. And prior to his appointment to a professorship at Cambridge, he worked in industry for over 27 years as a geotechnical engineer and was the founding director of the Geotechnical Consulting Group. And in doing that, he has also advised on numerous tunneling and major civil engineering projects in the UK and worldwide, including the Jubilee Line Extension, Crossrail, HS1 and HS2. He was appointed an independent crossbencher in the House of Lords in 2015, and Lord Mair was until recently a member of its select committees on science and technology and on risk assessment and risk planning. He is presently a member of the select committee on the built environment. Now I want to hand over to Lord Mair, who will explain the format of the debate and introduce the motion and the speakers.
Well, good evening to all of you. Welcome to the Cambridge Union. I'm going to set out the format of tonight's debate. So there are 3 speakers on each team. Each speaker will be allocated 7 minutes to make their case. For the speakers of both teams, you can, if you wish, address the speakers of the other team during their speech for points of information. You need to very clearly shout on that point or point of information. I hope that's not used too often. It's a means of politely interrupting. The speaker can then choose whether or not to take up that interruption. So you have to respect the choice of the speaker. Also, no points of information can be raised during the first or last minute of a speaker's time. And I'm afraid no points of information can be taken from the audience. It's only the three speakers on either side that can use that device. So after the first 4 speakers, there will be an open floor discussion for around 20 minutes, which we very much hope many of you will participate in. And you'll have up to 2 minutes or thereabouts to make your point or ask your question. And anyone is, of course, welcome to take part in that. When you come to be voting, which will happen towards the end of the proceedings, you obviously need to decide who you felt delivered the most persuasive argument. And for those of you not familiar with voting, you vote with your feet in this institution, you leave the room and you go either into the ayes lobby if you believe in the motion, or you go into the noes lobby if you disagree with the motion. And they're just by the doors here. This is being recorded and live streamed, this whole debate. Photos will be taken by the organizers, so please refrain from using any flash photography during the debate. There is no fire alarm test planned, so if an alarm goes off, please follow the fire exit directions to the lawn in front of the building. And a final note, a really important person here is Damien Palin, who is the debate secretary, and he is the timekeeper. So Damien will fiercely warn you when you have just 1 minute left, and then when you are out of time. So now, moving to the motion of the debate, the motion is road infrastructure. This House believes digitalisation is the most effective pathway to net zero. So I'll say it again, because it's rather important. The wording is so often important on these things. This House believes digitalisation is the most effective pathway to net zero for road infrastructure. So now, before we start, just to present to you the speaking members of each team. So, proposing that motion, firstly will be Professor Jennifer Schooling of Anglia Ruskin University. There'll be Dr. Kyriakos Kantorakias of Didyme, and Haritha Jayasinghe from the University of Cambridge. Those are our three proposers, and our opposers are Elliot Shaw from National Highways, Stephen Elderkin, also from National Highways, and Abbas Suliki from the University of Cambridge. And I'll introduce them more just before each one of them is to speak. So, starting with our first speaker, Professor Jennifer Schooling. Jennifer, her research explores the socio-technical aspects of digitalisation at the city scale, focusing on governance and ethical innovation to enable delivery of digital solutions for public value creation. She's co-director of the DARE Research Hub for Decarbonised, Adaptable, Climate-Resilient Transport for a Sustainable Future. She also carries out research on decarbonisation of construction through data. She was previously a very close colleague of mine, the director of the Cambridge Centre for Smart Infrastructure and Construction, CSIC. She was lead author of the Carbon Reduction Code for the Built Environment, and she sits on a number of committees, the Secure Connected Places Advisory Board, the Infrastructure Client Group's Digital Transformation Task Group, and the Institution of Civil Engineers Decarbonisation Community Advisory Board. So, Jennifer, the floor is yours.
Thank you very much, Lord Mayor. Ladies and gentlemen, Lord Mayor and my fellow debaters. Today I stand before you to propose the motion that this House believes digitalisation is the most effective pathway to net zero for our road infrastructure. When you can measure what you are speaking about and express it in numbers, you know something about it. But when you cannot measure it, when you cannot express it in numbers, your knowledge is of a meagre and unsatisfactory kind. It may be the beginning of knowledge, but you have scarcely in your thoughts advanced to the stage of science. So said Lord Kelvin in 1883, and who am I to gainsay him? In an era when climate change poses an existential threat to our planet, it is imperative that we leverage every scientific tool at our disposal to achieve net zero emissions as quickly as possible. But crucially, we need to be able to do as Lord Kelvin said, to measure our processes, to understand how each one contributes to the greenhouse gas burden we are imposing on the planet, and to measure our progress in reducing that burden. So I hope to convince you today that digitalisation, that is the integration of data and digital technologies into all aspects of our lives, offers unparalleled opportunities to transform the way we build, manage, operate, and use our roads in ways that are both sustainable and efficient. Ultimately, we need to use data as an engineering tool to mitigate climate change. Data can enable better design, more efficient use of resources, reduction in waste, and time and cost, and it can improve safety and increase infrastructure resilience. All critical factors in reducing carbon emissions from our built environment. Without data and the analysis that digitalisation itself brings, we can't measure our progress or even be sure we are on the right path. The significant reduction in the cost of storing, processing and transmitting data in recent years is driving digital transformation across all our industries. But to date, the focus in infrastructure and transport at least has been on the potential of big data to drive efficiency and profitability of infrastructure and construction. However, there is huge potential for new data and analytics to contribute towards the decarbonisation of the transport sector and our road systems and enhance its resilience to the impacts of climate change. This data really enables us to optimise the performance of both our new and our existing assets. Reducing carbon requires engineers to design for the whole life of an asset, understanding its intended use, and collaborating with asset managers from the beginning of the project to anticipate the future information requirements. This, in turn, enables a whole-life, value-based decision-making process for asset management, a move to risk-based maintenance, and the future-proofing of our assets in relation to potential impacts of climate change. Using data about the performance of our physical assets enables us to calibrate our design models, reducing conservatism and over-design, and hence reducing resource use and the carbon through better design. Studies at CSIC have indicated that many of our assets are only using 20% of their ultimate limit state strength, bringing opportunities to achieve at least a 50% reduction in emissions through less conservative design, combined with increased digitalisation of construction processes to ensure quality. Which brings me to my next point. Using digitalisation tools, such as digital twins, to manage construction processes helps reduce waste and manage the quality of the construction, allowing us to be less conservative in our designs and in our material specifications, opting for more resource-efficient, less carbon-intensive choices. And my own research into decarbonising construction shows that if we had better data and used it better, we could reduce the carbon emissions from our current processes and materials by 40%, just by improving the efficiency of our designs and processes and construction, and giving us the confidence to use lower carbon concrete and steel specifications. Shifting our focus now to our existing assets, deploying data-driven smart infrastructure solutions to these assets enables owners and operators to get more out of what they already have, increasing capacity, efficiency, reliability, and resilience, while reducing the need for new build and the associated carbon emissions. This includes activities such as monitoring the condition of our assets using sensors to manage our maintenance interventions more effectively, targeting them when and where they're actually required, rather than simply reacting to failures or carrying out maintenance on a planned schedule on assets which may not actually need it, both of which result in unnecessary carbon spend. However, we also need to consider how we use our transport systems. The majority of our current transport carbon emissions is user carbon from our vehicles. And the proposed path to eliminating these emissions relies on electric vehicles, but these in their turn require investment in substantial amounts of charging infrastructure. And electric vehicle uptake is currently afflicted by low adoption due to issues such as range anxiety and concerns about the availability of charging points. In addition to which, internal combustion engines are going to be with us for at least the next 15 years. Again, digitalisation offers us a solution. Using digital data analytics in tools such as Google Maps to plan our routes and advise on driving styles can reduce our user carbon in current internal combustion engine vehicles, and for electric vehicles, extend the range and enable us to plan better for charging, hence reducing demand on the grid and charging infrastructure, and enabling us to get to full electrification confidently. Digitalisation is also crucial for monitoring the outcomes of things such as implementing nature-based solutions, which can offer low-carbon solutions to, for example, flood management, improve data regarding the performance of such solutions, enabling us to learn what works best and accelerate the uptake of these low-carbon biodiversity-enhancing measures. So in conclusion, digitalisation offers a comprehensive and effective pathway to achieving net zero emissions. It provides us with the data and tools needed to make informed decisions about climate action. Big data analytics and AI can model the impact of different policies and interventions, helping governments and businesses to identify the most effective strategies for reducing emissions. Digital platforms facilitate collaboration and knowledge sharing, enabling stakeholders to work together towards common goals. Using data and digitalisation tools will lead to better informed, sustainably grounded decisions to ensure that our road transport systems really are fit for a net zero future. Thank you very much.
Thank you, Jennifer. for your stirring introduction, your proposition. So joining us now as the first speaker from the opposing team is Elliot Shaw. Elliot is Chief Customer and Strategy Officer at the National Highways and was appointed to the National Highways Board in January of this year. Within National Highways, Elliot is responsible for the strategic development of National Highways Network, the organisational business improvement agenda, analytical and economist functions, relationships with key statutory and regulatory bodies, customer service and communications, and corporate affairs activities. Before joining National Highways in 2016, Elliot was Transformation Director at the Ministry of Justice and has held a number of senior civil service positions at the Ministry of Justice and Department for Transport, with his early career spent as a management consultant at Accenture. He has a BA in Economics and Politics from Durham, a Master's in Public Administration from Harvard, and he's a Fellow of the Chartered Institute of Highways and Transportation. Elliot, you have the ears of the House.
Good evening, everyone, and welcome to this evening's debate. My name's Elliot Shaw, and I'm the first speaker of the opposition team. And we believe that while digitalisation certainly has its benefits, it is not the most effective pathway to achieving net zero in roads infrastructure. And to demonstrate this, I'm going to present 4 critical points. Firstly, that we need to define what is meant by some of the key terms in this motion. What do we mean by the most effective? And what do we mean by net zero highways infrastructure? Secondly, given the scale of the challenge, I will argue that we need pathways that we can be truly confident will deliver carbon reductions at scale and at pace, and that digital simply is not there yet. Thirdly, I'm going to set out a case that there are other, more effective pathways available to delivering net zero roads, and they demonstrably are more effective than digitalisation. And finally, I'm going to argue that digitalisation actually isn't a pathway to net zero at all. It's arguably an enabler, and as such, it could actually make things worse rather than better. Firstly, the motion that's been put forward is that digitalisation is the most effective route to decarbonising highways infrastructure. This is not that digitalisation plays a role in decarbonisation, or even that it plays a very significant role. To support the motion, you need to be convinced that digitalisation is the single most important way of decarbonising our roads, that nothing else will have a greater impact. And I think that is a high bar. The motion also talks about getting to net zero in road infrastructure. And I want us all to be very clear what we mean by this. When we talk about net zero roads, we need to talk about the construction, the operation, and the use of highways. Because decarbonising infrastructure can't just focus on the infrastructure itself. We need to look at the whole life carbon impact of that infrastructure. For example, if I had 100% net zero carbon materials, but I then used it to develop a massive coal mine that spewed forth carbon dioxide emissions for years to come, I don't believe that that is delivering net zero infrastructure. And this approach is reflected in all of the global decarbonisation standards, e.g. PAS 2080, the global standard for infrastructure carbon management, focuses on whole life carbon impact. Similarly, last year, the Supreme Court ruled that we need to consider the downstream greenhouse gas emissions from any infrastructure that we develop and use. And in roads, this holistic approach is critical, as most emissions are not in the infrastructure, in the steel, the carbon, the asphalt itself, but in its use. So we see that about 2% of emissions in roads are due to construction, renewal and operations, but 98% of emissions are about its use. They're about people driving on the road network in their cars, their vans, their HGVs. So when we talk about net zero in roads, we need to focus on that use, because that's where 98% of the carbon emissions are. Secondly, I would argue that we need credible pathways that deliver at pace and at scale. Roads are responsible for around 25% of the country's carbon emissions, so we need solutions that deliver at scale. But we also need pace. The Committee on Climate Change has argued that transport emissions need to reduce by nearly 50% by 2030 and a 90% reduction by 2040. And digital can help that. In operations, digital can help us to make more effective use of existing roads, so we do need to construct less. And better use of data may reduce the carbon emissions from road construction. But remember, that is tackling the 2% of road emissions, not the 98%. In the 98%, in that usage, digital technologies, for example, like Zoom, Teams, etc., may help people travel less, but I don't think that's a credible pathway to net zero. We're already seeing traffic back at pre-COVID levels on our roads. So thirdly, I would argue that there are other pathways to net zero roads that are more credible and more effective at the moment than digitalisation. For example, the Committee on Climate Change looked at the balanced pathway to net zero in surface transport, which is almost entirely roads emissions, as part of the sixth carbon budget. And according to the Committee on Climate Change, over 2/3 of the carbon reductions needed to get to net zero in roads are going to be due to zero emission cars and vans. And that will be delivered through electrification, not digitalisation. Around 15% of the carbon reductions are due to be delivered to zero-emission HGVs, which will be through electrification and new fuel technologies like hydrogen. Again, this is not digitalisation. Around 18% of carbon reductions are going to be due to behaviour change, getting people to travel less, to walk or cycle for short journeys. Again, this is not digitalisation. And in fact, when you look at the Committee on Climate Change's pathway to decarbonising surface transport, digitalisation is entirely missing. It is about electrification, alternate fuels, and behaviour change. And that is also true when we look at the Committee on Climate Change's balanced net zero pathway for the economy as a whole. Again, that pathway focuses on electrification, low carbon fuels, carbon capture, and again, digitalisation isn't mentioned as a pathway to net zero. So finally, I'd question, is digital even a pathway? The Cambridge Dictionary defines a pathway as a series of actions that can be taken in order to achieve something. And there are several credible decarbonisation pathways in roads. Electrification takes carbon out. Low carbon materials take carbon out. Behaviour change takes carbon out. Digitalisation makes infrastructure and operations and vehicles smarter, but it doesn't necessarily take carbon out. Digital operations can help us get more vehicles on our roads, but in an ICE world, that could mean more carbon, not less. Smarter vehicles, such as connected or autonomous vehicles, could make cars more attractive. Again, that could mean more carbon, not less. And that's before we even get to the massive energy demands of digital solutions like AI. So in conclusion, while we recognise that digitalisation may have a role to play in the decarbonisation of our roads, it clearly isn't the most effective pathway to net zero. Given the scale and pace of decarbonisation needed in our sector, there's a risk we could focus on tinkering with exciting new technologies while the world literally burns. And other pathways like electrification clearly offer a more credible pathway to net zero. Thank you.
Thank you very much, Elliot, for your very stirring speech. We're now going back to the proposing team, and the second speaker is Kyriakos Kantorakias, who's the founder and CEO of Didymai. Kyriakos gained his PhD in sensitivity analysis and uncertainty quantification of chaotic systems from Imperial College after working as research associate in the parallel CFD and optimization at the National Technical University of Athens. And the purpose there was conducting computationally efficient statistical analysis in aerodynamics. After Imperial, Kyriakos took up a role with Palantir Technologies. Palantir partners with some of the most incredible organizations in the world to improve their operations via data-informed workflows and first-class deployment services. And through them, Kyriakos was able to strategize about how to optimize organizational performance and tackle their problems with data, which has led to the formation of Didymai, a spin-out company from the Digital Roads Prosperity Partnership. Didymai provides a platform that enables engineers and designers from all disciplines to share information losslessly in real time. Kyriakos, over to you.
Thank you, Lord Mayor. So, as in every debate, the best way when you have a losing argument is to change the subject. Here today we're about to debate whether or not digitalization for road infrastructure is the most effective path to net zero, yet we're here speaking about when cars are actually going to electrify, with all due respect. There's not much we can do about that, and there is plenty of argument what goes on the vehicle side and how green and carbon-free those EVs actually are and how long it's going to take us to get there. But what I want to do is to focus the debate back on the actual conversation, what matters. Only focus on what you can control. Yes, we should be supporting EV vehicles, but we should think about that from the road infrastructure perspective and making sure that it is there when it's needed to support it. Additionally, we spoke about the whole life cycle management of the carbon that goes out from the highways and alternative fuels. Ladies and gentlemen, to me, the obvious answer here is that that is not even simply remotely possible without having first-in-class, world-class digital technologies that allows us to measure. So, is it the most effective path to net zero? Maybe that's the subject for debate, but what we all agree is that digitization needs to happen, yet it has not happened. We're the least digitized industry in the world. We have recently been surpassed by agriculture. We're losing to agriculture. Now, net zero. There's the net part and there is the zero part. And let's break those two. To get to the net part of the equation, what we need to do is to be able to measure emissions, the source and the sink, and do the carbon accounting. This requires extensive digitization in all parts of the supply chain, from planning, design, construction, operation, maintenance, retrofit, and even decommissioning of the asset. We need to know everything to do the accounting. If you can't measure, you can't improve. Now, to get to the zero bit of the net zero, what we need to do is optimize the operation of the assets. And what I'm talking about is what we can actually control. Particularly in highways infrastructure, where we're not building many highways anymore, so our main task is to operate them and maintain them as efficiently as possible. Decision-making around operating such an asset is a solved problem in every other industry, but not us for some reason. Monitor the asset, gather data, analyze, predict, intervene, and measure against specific performance indicators. Yet most of our national infrastructure is unfortunately not very digitized. The supply chain is not exchanging information efficiently, or there is no information to exchange because we're still collecting things on a piece of paper once in a while. So if we can't measure, how on earth are we actually going to improve our infrastructure? How are we going to benchmark ourselves? So digitization, it's widely agreed. It makes the adoption easier because it helps us measure it, and it can help us justify the expense against specific key performance indicators. And this is the key here. So let's dive into those. Digital twins create digital replicas of a physical asset, which allows us to simulate and predict performance. This means that we can optimize resources and how we allocate them, energy, water, materials, battery, whatever it is, which is the only way that we can get to even measuring the substantial reductions in the carbon footprint of both construction and operational phases of any asset. An example from my company. What we do is that we collect data once in a while from passenger vehicles. We are doing this right now. We learn about the highway, and what we can do is that we can predict when a pothole is actually going to develop and intervene at the right time, before it becomes much larger and much more expensive to fix, and with a much larger emission associated with it. This is possible right now, and this is exactly the low-hanging type of fruit that we can actually take advantage of, and they have a very outsized impact. Around material waste, the ability to test scenarios in the digital space before the implementation reduces the need for physical trial and error, which is extremely, extremely expensive and wasteful. We anticipate issues, and we can optimize materials and what we're actually using to avoid any unnecessary resource consumption. Again, very basic stuff in any other industry, but not in ours for some reason. This has a tremendous impact on the supply chain efficiency by connecting every phase of the construction Through digital platforms, we can actually make informed decisions with real, up-to-date information. Again, what generally seems to be a foreign concept, but it's what we should be aspiring towards. And yes, I'm sure there's an argument around carbon neutral materials. I'm sure that we can go and identify some way to make concrete without producing any carbon footprint. But in practice, to do that, we need the digital domain. Right now, there are many companies that are around using AI in order to be able to have a very good estimation and simulate how materials are going to mix together and how they're actually going to perform before going into the physical part of the trial that's also expensive, which in many other industries has reduced the cost of developing new materials by about 2 orders of magnitude. There's a revolution going on as we speak, and that is enabled, no, that is made possible by digitization. So we need to also think about being able to be proactive in our monitoring. 1 minute. If we can monitor our assets in real time, this allows us to go and proactively intervene. I cannot stress how crucial that is in an industry that wastes so much resource. And this reduces the need for replacement of the infrastructure and the embodied carbon that is associated with new construction. We can also dynamically adjust our operations to match the real-time demand, minimizing emissions and the overuse of energy. Again, very low-hanging fruit. So the only option that the opposition has in this debate is to change the subject. And I understand it, it makes sense. Digital is winning everywhere and you need to do it. And there's plenty of good argument around it. But to speak about the most effective path, it's been historically proven in any other industry, it needs to happen within construction, within highways infrastructure so that we can get there. Thank you very much.
Kyriakis, thank you very much. And we're now going to hear from Stephen Elderkin. Steve became Director of Environmental Sustainability at National Highways in 2021. Previously, he was Chief Analyst for National Highways when he had responsibility for advising and assuring value for money from investment in England's strategic road network. National Highways, or Highways England as it was originally called, was established in 2015 and was given substantially increased delegations and responsibilities. Stephen built a new analytical team of transport planners, economists, operational researchers, and evaluation experts to set the standards and provide the analytical advice and assurance for decision makers. Stephen has a decade of experience as a government economist. Prior to joining National Highways, he worked in central departments, DEFRA, DEC, BIS, with a particular focus on environmental policy. Steve, the floor is yours.
Thank you. Good evening, and thank you for the opportunity to speak today. So the proposers seem determined to focus obsessively on 2% of the problem, but 98% of the challenge is emissions from vehicles. These can only be reduced through cleaner energy, reduced vehicle miles, or improvements to energy efficiency of vehicles. This requires electrification, integrated transport planning, or getting over ourselves and being willing to share a vehicle with somebody else. Digitalisation can help optimise, tweak, fettle. I agree, it's an absolutely invaluable tool. I'm using digital tools today. But it is not a pathway in and of itself. And it comes with the cost of exploding energy consumption for data transmission, storage, and processing. So let us turn to the fundamental source of emissions from road infrastructure, the use of fossil fuel-powered vehicles. Because 98% of road infrastructure emissions come from vehicle tailpipes, this must be where we focus. Most countries' emissions from roads have been stagnant or increasing. Globally, between 1990 and 2022, transport emissions have grown by 1.7% a year. An exception is Norway, whose road transport emissions are rapidly reducing by over 7% between 2022 and 2023. This is because of their choice of pathway, an electrification pathway. Over 90% of new cars sold in Norway are now fully battery electric. From next year, it will have to be 100%. As older vehicles are scrapped, they are removing the use of fossil fuels for road transport, directly addressing the root cause of emissions. Tinkering with digitally enabled optimization of the road transport system will not drive the fundamental change required to achieve year-on-year reductions of this scale. In the UK, 9 times as much freight moves by road as by rail. A third of emissions on the strategic road network come from heavy goods vehicles. Even with a massive expansion of rail freight, much more stuff will continue to be moved by roads. Digitalisation will not decarbonise lorries, and it will not move the net zero loo roll and baked beans that we all need. Single occupancy vehicle trips are an energy intensive way to travel. This matters because generating enough clean energy to meet demand is straining the credible deployment of grid upgrades and wind turbines. Globally, wind and solar generation has been deployed faster than any previous generation technology. However, energy demand has grown faster. The result is that we are using more fossil fuels than ever. Nearly 2/3 of car journeys in the UK are single occupancy. Behaviour change, improvements in public transport provision, better active travel infrastructure can slash the energy demand per passenger. Amsterdam is a global leader in active travel. 60% of journeys are active, but this wasn't inevitable. In the 60s, the city was congested with traffic. The pathway away from car dependence was taken long before digitalisation existed. With the purposeful policy, there was concerted investment in cycling infrastructure. Urban road schemes were cancelled. Public transport investment was substantially increased. Better integration was achieved between modes. Moving away from fossil fuel vehicles and making alternatives to road transport more attractive are more effective pathways than digitalisation. The switch to digital comes with energy and emissions cost. The digital industry is a major and growing user of energy. To service the exploding processing and data storage demands that digital technology requires, data centers' energy use is growing at 20 to 40% a year, according to the International Energy Agency. Globally, data center electricity consumption, not even including crypto, already exceeds that of the UK. Double the UK if you include data transmission. In countries where data centers are concentrated, the strain on electricity grids can be significant. 18% of Ireland's electricity consumption was in data centers in 2022, tripling since 2015. Microsoft recently signed a contract to restart a reactor at the infamous 3 Mile Island site to provide the enormous continuous supply of electricity that one of their AI data centers would require. A McKinsey study estimates that on average, a connected car will generate 25 gigabytes of data per hour. 95% of cars are expected to be connected by 2030. Autonomous vehicles can be expected to produce significantly more data again. The road industry's digital footprint is exploding. If digitalisation improves customer experience, then it will likely increase emissions. Digitalisation will, I am sure, improve customer experience. If it reduces the cost, financially or emotionally, of travelling on the road network, we can expect road use to increase. The intuition for this rebound effect is simple. If things are cheaper or easier, we tend to do more of them. Digital technology may unlock more capacity on our roads, allow smoother, more reliable, safer journeys. This will make it more attractive to travel by road, with the result, a digitally induced rebound effect. Increasing the number of journeys, with less than 4% of miles travelled driven by electric vehicles, according to the RAC last year, this will largely cause more miles to be driven by combustion engine vehicles. Is it a pathway at all? The National Energy System Operator recently produced a report on clean power. It had 2 pathways in it, one with lots of renewables, one with more dispatchable power. Digitalisation was listed as an enabler, along with several others. So, in conclusion, digitalisation does not address the main source of emissions from road infrastructure, the combustion of fossil fuels in vehicles. I'm sure digital roads can really help the operation of our network. We're not arguing that. But what we are saying is it's not going to be the most effective. And worse, digitalisation is going to place pressure on energy demand and the consequent emissions. Digitalisation does not define a direction of travel or a pathway for decarbonisation. Digitalisation cannot be the most effective pathway to net zero. Thank you.
Steve, thank you very much. So we've had 4 very compelling speeches. And at this point in the debate, as I explained at the beginning, we're going to now open up the floor for opportunities for you to make your points or ask questions, and we'll have around 20 minutes for that. So I don't know whether people have seated themselves deliberately on this side, which is meant to be the proposing side and opposing side, or whether it just happens that's where you're sitting. Is there anybody who would like to speak in support of the motion on either side? Now, if you would like to speak, please raise your hand, and a microphone will be brought to you. It's important that you have the microphone in your hand before you speak. Who would like to make a point either way? It doesn't have to be proposing or opposing, either way. So, okay, over here, please, and then over on the other side.
I have to say I am opposing the motion, and it's not remotely because my 2 bosses
Could you
are sat
introduce
over there.
yourself?
Esther Gordon-Smith, National Highways, Carbon and Climate Lead, and I work for Steve. He didn't set this up, we're all good. I wish that I lived in the proposer's world, but I'm also glad that I don't. And to explain that, it's all very well assuming that computers and robots can predict when a road pavement will fail and go and fix a pothole, but they can't actually account for a lorry fire. The strategic road network reliably serves society and allows for randomness, human error, and perverse decisions. And the majority of our network, millions of tons of gloriously static stone, concrete, and asphalt, functions without software upgrades. But I'm also glad that I don't live in the proposer's world, because it's simply not true that you can only improve what you measure. Human history is full of tales of improvement before digital tools became available. For example, my right to vote and even to take a degree in this fine university was won before the internet was invented. The internal combustion engine was invented in the 1860s or 1870s, depending who you ask. The first electric carriages, recognizably electric vehicles, were invented in the 1830s, 50 years before. So there is a strong and proud history of electric vehicles. And to conclude, as a kind of summary, I bring to the House's attention the national data set on the adoption of electric vehicles, which has an interesting signal in approximately the 1970s, 80s, 90s. It turns out that the large number of battery electric vehicles undertaking those last mile journeys that we all talk about were humble milk floats. And for that reason, I support the opposing team. Thank you.
Thank you very much. Now, there was someone, if you could just introduce yourself just as you start, please.
Hello. Jeremy Morley, I'm Chief Geospatial Scientist for Ordnance Survey. This isn't exactly for or against, although maybe it plays more to the against. I think I'd like to question an assumption in all of the teams here. The proposition itself doesn't particularly mention UK or even Western nations in its, in the proposition itself. So maybe I'd like the teams to reflect a bit on whether digitalisation is really the key internationally, and does it really affect Africa and South America and other such nations in their road infrastructure as well?
Thank you. There's a person with a hand raised just in the front here, please.
Wolf Mangelsdorf from Bureau Happold, lead design technology and innovation there. I'm opposing the motion, but I'm asking, are we asking the right question? Because we seem to be putting up two extreme positions, maybe for the sake of the debate, whereas I believe the truth lies somewhere in between. Digitization is, as far as I see it, a necessary condition, but it's not sufficient. And well, I think we should just meet in the middle.
Okay. Compromise is not allowed in this chamber.
I'm a foreigner, I'm not familiar with it.
Have we got any further contributions, please? Anyone who feels they'd like to? Yes, there's someone right over there. Thank you.
Hello, I'm a PhD student at the Department of Civil Engineering. Just a quick question, not opposing or in favor of the promoting team. Just saying, we are talking about electrification as if it was a magical thing that is going to solve all the CO2 emissions. However, all the components that we need for electric cars, right, are made with rare materials, also for normal cars. That is true. But yeah, all those components need to be mined or obtained through mining in countries in Africa, for example, in which the regulations for carbon emissions are very, very low, right? So if more, let's say, if electrification progresses somehow and we end up building more cars, electric cars, we will be putting more stress on that mining and generating more CO2 as well, right? So just saying that it is, I think it's a good argument, but it's not going to make, let's say it's not definitive, okay? Thank you very much.
Okay, thank you. I think there was just behind you, there was somebody right there, yes.
Thank you. My name is Percy. I'm a PhD student working on building defect classifiers and so on for the roads here. I've actually got a couple of points, particularly pointing towards the opposition. So the first point being a path, you decide to define pathway as the means to deliver the final goal, which is to achieve net zero in this motion. But I would also argue that there are lots of steps that leads you to a pathway that are equally important and cannot just be dismissed as enabler or a step towards the final goal. You can't have 10 strikers playing in front of the pitch without the central midfielders and the central defenders that are pinnacle, supportive, and I would say even foundation of building all the kinds of things that delivers the final mile. In this case, the digitalization, at least is in the modern ways of electrification or adopting renewable energy, digitalization is so vital in order to deliver all these benefits that can be done by electrification or by the adoption of renewable energy. So like maybe the proposition side can also think about like how you do in the concluding speech of like how these digitalization could be, you know, a foundation for all the kinds of means in order to deliver the final goal of achieving net zero. The second point being that I think a lot of electrification things might have, or like you can have electric vehicles since maybe the 1800s, but then at least for the modern implementations of it, which I suppose, for example, a lot of electric vehicles that we have today that are actually bringing us the benefits of net zero or reducing carbon emissions, all of them are going to be connected to the grid and be measuring how much carbon you can save, how much carbon emissions that you can reduce. I think a lot of those would rely on lots on digitalizations. Without those, there would just be basically a car changing from a diesel engine into an electrical motor and changing a fuel tank into a battery pack. And I suppose with all the kind of net zeros that we have in mind, a lot of digitalizations will actually be needed. Thank you.
Okay, thank you. There's a person over here, please, and then we'll come back. There's some other hands I see raised over there. Can we come over here?
Thanks, Navina. Joe Rice-Jones, Bentley Systems.
so refraining the question is always a great tactic. I'm just struggling to understand how EVs are not a form of digitalisation.
Okay. Thank you, Joe. Sorry, going back over here, please. Sorry, you're having to walk backwards and forwards.
Thank you. I'm Shang Shen from Sustainability and Environmental Consultancy Temple Group. Can I ask a question about National Highways Net Zero strategy? So one of the key measures for decarbonization based on the Net Zero strategy is to planting 3 million new trees, which represents largest known cost within this strategy. It's probably about, based on market cost, it's probably about 4 to 8 times the market cost. However, it's been reported during the last 12 months, just example, along A14, 70% of the tree newly planted have already been dead. So I was just wondering, in your opinion, is this still the most feasible option in terms of decarbonization?
Okay, thank you. I think I see that the opposing team are scribbling hard there. So I think that Abbas, when he makes his speech, he will address what you just said. Now, some more hands up here, please.
Hi, I'm Michelle Cameron. I'm a postdoc at Cambridge. So I think that technology and digitalization are more of a band-aid to postpone the impacts. And this has been the case for a very long time. I mean, we had issues with horses, horse manures on road, farmlands used for feeding horses, food shortage. And hooray, now we have ICVs. And the issues with ICVs that we had were like smogs, and now the biggest issues of the century, carbon emissions. And sure, now we have EV, autonomous cars, battery management systems, all to support, range anxieties. But EVs also have emission issues, especially, again, mining of the materials that was mentioned before. So to what extent do we rely on technology and digitalization? I mean, the way to solve is how we use our infrastructure, like improve utilization, resource use, rather than solely depending on digitalization. And I think that digitalization technology is also responsible for sustaining such high population, which in return supports massive impacts associated with population. So the core of the issue is how long will we rely on digitalization as a band-aid rather than focusing on the core behavior change in industries and users? Thank you.
Okay, is digitalization a band-aid? So there's a question, someone with their hand up here, please, and then at the back over there.
Hi, I'm Annette Pass. I'm Deputy Chief Scientific Advisor at the Department for Transport. So I think with so many of these debates, a lot of this comes down to semantics, doesn't it? So the opposing team have talked about their definition of carbon from road infrastructure being about the vehicles, whereas the proposing team have very much focused on the infrastructure. So a lot of these things fall down to semantics. What do we mean by pathways? What do we mean by digitization? I think the thing that I would think about is the fact that we live in a very interconnected world in which we don't make any change without changing a very complex system. And how do we understand complex systems? We understand it through data. And I know, Steve, you've worked as a chief economist and analyst, and Elliot as well in the civil service, and you'll know how important evidence and data is to making decisions. And so therefore I would say that maybe a lot of that evidence is actually going to come to you through digitalization. So while we can debate the meaning of pathways, I think without digitalization we don't have a very strong route forward that politicians will agree to without data. And I would think about the story of the person who developed the routing system for UPS, I think it was. There's a very good TED talk there called Grit. And he talked about how it took him 10 years to convince the team at UPS that digitalisation was the way to optimise those routing for parcel deliveries. And after 10 years, finally, he managed to convince them that it was. And that organisation saved a huge amount of money and a huge amount of carbon. So I am in favour of the proposing team. Thank you.
Thank you very much. Somebody at the back over there. 2 hands up in the back over there.
Hi everyone, I'm Sripriya. I'm a senior research associate. I'm with the against the team. So I believe that digitization can give all the data and point out to the direction and the source of the carbon emission, but the actual action that has to be taken on the real thing. It cannot be done with the digitization. Digitization, I agree that it can point out to the direction, it can optimize the process, but actual carbon emission, that is what we need to address, and that comes from a lot of other physical elements that we need to address rather than being solely dependent on digitization. That's my view. Thank you.
Okay, thank you. At the back, two people.
Lilia from Digital Roads team. 5 to 15 tons of CO2 it costs to produce one piece of gantry, with 50 to 200,000 pounds cost. Some of these assets do not need to exist in the physical world. With proper digitalization, these assets and communication to the vehicle in the digital world, these assets do not need to exist in the physical world.
Okay, there was another hand up. Was that a supporting hand?
It was supporting, but I'll cut in too. Hi, Tom Kelly. I'm on Digital Roads like Lilia. I think I'll just draw our attention to the phrase, the most effective pathway. So all we need to do to, what do we say, to negate this proposal is to suggest one better pathway to net zero than digitization. And we can pick from many thousand absurd pathways. We could choose nuclear war, right? We could choose anything. We could choose everybody going home and like never coming out of their house again. All of these are better pathways and faster pathways to net zero than digitization.
Gentleman over here. That's 2. Okay.
Okay.
That intervention has created a lot of new thoughts.
Hello. Ian James, I'm the Head of Asset Management Strategy at National Highways. I wanted to pick up a point that was said in the first speech, actually, by Jennifer, where I want to stand up for our engineers a little bit here, because she stated that digital could allow us to, because we over-design our bridges, apparently. And I would disagree with that, because I think that our bridges need to last a long time, and they deteriorate over that time. And my mum always used to say, you buy cheap, you buy twice. So the idea that by making something cheaper and less high quality, we're going to end up with more carbon, I think you're going to end up doing it twice. The other side of this, I would say that our engineers are the people who interpret the data to decide what we do on our network, and I would argue that the idea that data will be the only thing that fixes this, I do not think so. I think the main driver will be the decisions of the people rather than the data itself.
Okay, Paul.
Paul Campion, TRL. Outside there in the real world, I'm sure everyone here agrees we need to do everything we can as quickly as we can to decarbonise. In here, we're going to die on pedantic hills. And with the greatest respect, I'm not sure I can agree that nuclear war is a better way to decarbonise, even if I would agree it's more effective. But in the same spirit, I can't conceive of how 8 billion people could live on this planet without the level of digitisation we already have. I don't think there's anything that we do or can do that is not inherently digital now, so I'll be walking through the Yes store.
Thank you, Raj. Thank you. Right, I think that may be a very good point to wind up. No, there's another hand here. just a couple of more interventions, and then we'll be hearing some more speakers.
Hi, I'm Yasmin, and I work in AI governance and ethics. I'm very interested in the proposition's argument about digitization, increasing efficiency, and reducing waste as a pathway to net zero. Because I'm very well aware that around 6 to 8% of the data that is currently being stored is not being used at all. And obviously, the opposition has argued about the resource cost of that data. So are we not simply digitizing waste and creating information and data for data's sake?
Okay, thank you. Final opportunity for anyone else from the floor. Yes, over here.
Stefano Cavazzi, Principal Scientist at Ordnance Survey. So in the spirit of digitalization, I asked ChatGPT which motion I should support, and the answer is clearly digitalization. I don't know if it's a self-preserving mechanism of ChatGPT, but I think I will trust that one and I will support the motion.
Excellent. Okay. Thank you. Well, we've reached the point now where we're going to hear our final speakers, one from each side, and our third speaker on the proposing side is Haritha Jayasinghe. Haritha is a PhD student in the Department of Engineering here at the University of Cambridge, and his research focuses on the digitization of industrial facilities, and it's conducted in partnership with Avina and BP, aiming to facilitate the automated creation of digital twins of industrial assets. He holds a bachelor's degree in engineering from the University of Moratuwa in Sri Lanka, specialized in computer science and engineering. His previous work includes construction progress monitoring through point cloud comparisons and developing computer vision applications for automated vehicle damage estimation. Haritha has a strong background in 3D data processing and deep learning and is passionate about conducting cutting-edge research to contribute to the rapid transformation of the world through computer science. Haritha, the floor is yours.
Thank you. What an incredible venue this is. Did you know that Teddy Roosevelt and the Dalai Lama have spoken here? So have Thatcher and Reagan, but we like to gloss over that. Now, many of you might be here for the first time. So I'd like to ask, how did you get here? I'm willing to bet that a lot of you were guided here by a digital twin. A digital twin that collects real-time information on traffic and disruptions, and which use that information to guide you and millions of others every single day, thereby feeding back into the real world. A digital twin that lets you plan your journeys on public transport or even tells you when your bus is late. I am, of course, talking about Google Maps. Google Maps has probably transformed how we use our road network more than pretty much anything else in the past 50 years. Yet we never think about it. We take it for granted. We don't think about the impact it has on how we travel. It was Nassim Taleb that said, technology is at its best when it becomes invisible. And this is exactly why we don't really think about digitalization. It's become invisible to us. But tonight, I want you to take a step back and to take a moment to truly understand the impact of digitalization in how we travel today and its impact on how we will travel in the future. Now, speaking of the future, Jennifer and Kyriakos have already shown you the massive impact that digitalization can have simply based on today's technology. But since this debate is about the future, I'd like to take a moment to speak about the future of digitalization. Now, one of the great advantages of digitalization is the rapid pace at which it's developing. Digitalization capabilities 1 decade ago are nothing like the capabilities that we have today. AI 10 years ago was barely beating humans at image classification. AI today is transforming every single aspect of our lives. So imagine what the future of digitalization can hold. And even things like driverless connected cars are no longer a thing of the future. We see them popping up everywhere. Waze was born right here in Cambridge. And digitalization is what's enabling the adoption of these connected cars. Research from Cambridge shows that connected cars are going to reduce traffic by at least 35% through optimized traffic flow and reducing idling. And on top of that, The capabilities of emission saving through reducing disruptions and accidents, even lorry fires, are massive, because when you have connected cars talking to each other, you're not going to have these accidents and disruptions. And on top of that, AI can design public transport systems of the future, chain together multiple systems so that taking public transport will seem as seamless as taking a personal taxi. The possibilities of AI optimization are truly endless, and digitalization is truly the foundation that it's going to be built upon. Now, Kyriakos has already shown you how we must focus on what we can control. But for the sake of argument, let us take the opposition's argument at its face value. Imagine that we must control the road emissions of the users, the behavioral changes, as the opposition put it. Let me show you how digitalization is still the best pathway to achieve this. Why do I say this? Throughout the many false narratives brought forth by the opposition today, and there were many, I think the greatest one was this concept of a false dichotomy, where it was digitization on one side and all of these other things on the other. We believe that it does not have to be a false dichotomy, because digitization is not a solitary path. It is a road, it is a path that takes us to all of these different multiple approaches. It's a road that enables them, it's a road that leads us to them, and that is how it's going to really, really help us achieve net zero. Because it makes the adoption of all other forms of emission reduction faster, easier, cheaper, painless, and accountable. Pace and scale, as the opposition put it. And yes, we do need behavioral change. The hard truth is that we haven't achieved net zero largely because the public wasn't motivated, because we were not motivated. At an individual level, we use disposable plastic, we buy fast fashion, we take cheap flights to Europe, and we throw up a fuss whenever the government wants to build a wind turbine near our houses. But the key role that digitalization can play here is that it can reduce that friction of adoption by making it easier for people to adapt these technologies. You see, we could introduce thousands of more buses on the road, subsidize train travel, or we could design better transport systems and make people actually want to take public transport. We could similarly discount EVs by spending billions, or we could create optimized charging grids that actually reduce the friction of people buying EVs, or even create systems that lead to less people actually needing to buy vehicles in the first place. And let's not forget the massive embodied emissions that are going to be in those batteries. Or, similarly, we could spend billions covering the UK with wind farms, or we could invest intelligently in green energy, but simultaneously reduce energy waste by optimizing traffic flow. So it is data and digitization that's going to be crucial for enabling this. It is the pathway that speeds it up, lets us measure it, and takes us to all these approaches. Now, a few rebuttals before I close. Just talk about high energy use. It has clearly been shown that the cost of digitalization is far outweighed by the benefits it gives us. The cost of creating a simulation, yes, it's going to cost a bit of money to have that data center running, but the physical versus creating a physical prototype, it's going to be so much less. And digital can drive down emissions while all these other technologies develop. And on top of that, the audience asked, what about developing countries? Digitalization can actually be adopted much faster than most traditional technologies. In India, there's 36 cars per 1,000 people, but in the US, there's 800 cars per 1,000 people. In India, there's 70% smartphone penetration, but in the US, it's only 80%. Look at that gap. Look at how much faster technology can be adopted. And the audience spoke about how we don't need to measure, but it was Florence Nightingale that showed us in the 1850s that used data to convince people that sanitation reduces mobility. It's much better than going about in the dark. So in closing, I want to take a moment to ask, what is the point of this debate? Why are we here? We believe that it's to figure out if we are on the right path. It's to figure out if we are getting everything that we can out of digital twins. It's to figure out if we are fulfilling this responsibility in this privileged position that each and every one of us in this house has to design these digital solutions to be all that they can be. And it's to understand the role of digitalization in this larger push towards net zero. Our goal was not to convince you that digital twins alone will take us there, or that we don't need to invest in clean energy. It's the opposite. We want to show you that digitalization is what makes their adoption faster, cheaper, easier, and possible. So in closing, I'd like to encourage you to vote proposition if you believe, as we do, that digitalization can be more than even what we've been envisioning so far, that it can be the backbone to usher in new technologies, and in short, that it will be the pathway that leads us to the net zero future of transport. Thank you.
Thank you, Haritha. So now we have our final speaker of the evening, Dr. Abbas Suluki. Abbas is a Marie Sklodowska-Curie Fellow on the EU H2020 MSCA Co-Fund Future Roads Fellowship Programme at Civil Engineering in the Department of Engineering here at the University of Cambridge. He's specialising in the field of pavement engineering and sustainable infrastructure, with a strong focus on geopolymer binders, ultra-low carbon alternative concrete, and material characterization. His academic journey began with a bachelor's degree in civil engineering from Sistan and Baluchistan University, pursuing his master's degree in highway and transportation engineering at University Putra, Malaysia, and completed his PhD in pavement engineering at the University of Bologna. During his PhD studies, he was honored as a Marie Curie Fellow and had the exceptional opportunity to pursue an industrial PhD, combining work and study. With his multidisciplinary expertise and a passion for sustainable infrastructure, Abbas continues to make significant contributions to the field of pavement engineering, paving the way for smarter, greener, and more resilient transportation systems. Abbas, we look forward to hearing you.
Thank you. Okay. So, good evening, everybody. Tonight, we are here to debate one topic only, and that is digitalization is the most effective way to achieving net zero in our road infrastructures. And for the sake of it, I didn't hear just one example from your side showing us that digitalization is the most effective. So that was really disappointing. And I hope that by now, our team has convinced you a lot, not all of you, at least most of you, that this is not actually the case. So we have challenged the motion in 4 key points: definitions, credible pathways, alternative solutions, and of course, the fact that digitalization is an enabler, is a tool. And I lost count how many times your side uses enabler, a tool, when you were discussing this. So that proves our point that digitalization, of course, is nothing but an enabler and a tool.
May I have a point of information, please?
Yes.
We already gave an example of how we can, simply by looking at the data from passenger vehicles, we can actually have a very good understanding of how the pothole is evolving and literally have a measured accounting of how much emissions we're giving. There were many other examples given, but just one.
Yes, thank you for that. But that, again, only refers to the 2% that we are discussing. So you're only focusing on the 2%. But thank you for that input. So just before I start my examples, at least I have a go at giving examples, I just want to set a perspective. So the average UK citizen each year produces about 6 tons of carbon footprint, right? So that's about 20 to 25,000 miles on your car, or for any reason that you like, travel between London to New York for 6 times. So that's 3 round trips. And speaking of New York, Trump is coming. So if I were the Paris Agreement, I would have a sad face on my face, sad look on my face. So the main point here is that how a policy, a new government can hugely affect our climate goals. And no matter how digitalized we are, how much infrastructure we have in terms of digitalization or digital firewall, that cannot save us from these challenges, political challenges. And going back to the consumption of energy, you can see a rise in Bitcoin prices, and that means more interest in mining Bitcoin. So when Bitcoin uses more than the power of required for Argentina or the Netherlands, that just shows how much energy Bitcoin mining is using, and that's going to put pressure on the digitalized sector. Now,
I fail to see how Bitcoin is relevant to the digitalization of our road infrastructure, because we're not mining Bitcoin here. We are debating how we deliver more effective infrastructure.
Exactly, that is a part of the digital infrastructure and it's consuming energy. So instead of using that energy for your good cause, you're using it to mining Bitcoin, where that energy could be used somewhere else. So, and speaking about policy changes, it's not always the opposite. We can see that speaking to your Google Maps, if you go back to 2005, Germany at that time, when Google Maps was born, YouTube was born, and Intel started producing multi-core processors, with the least digital aspects, Germany provided a toll on their truck system and managed to save 5 million tons. And also Sweden, within like 10 years, by increasing its biofuel share from 5% to 30%, managed to slash 20% of its carbon footprint from the transport sector. So these examples show how straightforward policies can outperform complex digital solutions in reducing emissions. And if you look at our own London and its ULEZ policy, it achieved 44% reduction in NO2 levels just within 10 months. And France has also used this in Paris, and they are aiming to reduce the carbon footprint by 40% by 2040, I think. And this is nothing compared to the 5 or 15% reduction we can see from intelligent traffic systems. And of course, talking about human behavior, I have no doubt that if you are in the market looking for a second-hand car, one of the options that you are going to check is the ULEZ compliant, even though if you're not traveling to London more than once or twice in your lifetime. So speaking about alternative methods, infrastructure changes. So Denmark and its cycling investment has reduced carbon footprints, and the Netherlands are trying to incorporate waste material and bio-asphalt in their infrastructures, and that will reduce the carbon footprint by 52%. And again, it's crucial to investigate the root cause, and that is the carbon coming out of cars. So 7% for Norway again, 1 year, 7% reduction. That's fantastic. Singapore and California are also targeting to reach 100% EVs in the near future. And we can't deny that digitalization plays a supporting role in these initiatives. It's crucial to recognize that these are not the main drivers of emission reduction in these examples. So I heard a lot of questions about GPS. Yes, you sit here in your car, you put London, you drive to London or anywhere. That helps you, enables you to reach London sooner, faster, don't get lost, but it's not driving you. It's you that doing all the work. So in conclusion, while digitalization has its place in our efforts to reach net zero emissions, it's far from the most effective pathway. The evidence clearly shows that policy-driven solutions, infrastructure changes, and shifts in behavior are more impactful. I urge you to vote no on this motion, not to deny the benefits of digitalization, no, not at all, but to acknowledge that there are more effective, direct approaches to achieving a net zero goals. And beyond this debate, I challenge each of you to consider what changes are you willing to make to help us achieve this net zero in the near future. The road to net zero emissions isn't paved with pixels. It's built on bold policies, innovative infrastructure, and individual actions. Thank you.
So, ladies and gentlemen, we've come to the crunch part of the evening's activities where you are going to be voting, I hope. Just to remind you, in case you had forgotten, the exact wordings of the motion are road infrastructure. This House believes digitalization is the most effective pathway to net zero. Now, there are through the doorway here, if you vote in favor of the motion, you go through the ayes door, and if you vote against the motion, you go through the noes door. The bell will be rung in 10 minutes, so please return to the chamber in time when you hear the bell so that you can hear the announcement of the vote. So from now, the division is open, the voting is ready for you to make up your minds.
time to announce the results, and I'll pass it back to Robert now.
So I'm sure you're all waiting in trepidation. I'm going to announce the results as follows. The ayes had 40 votes. The noes had 68 votes. And the other thing I would just, important thing I'd like to say, firstly, to congratulate all 6 of the speakers. They were, I'm sure you'll agree with me, were all excellent, as indeed many of your interventions were as well. But we have awarded a prize for the best of the 6 speakers, and there's a runners-up prize and the prize for the winner. And the runner-up, the judges decided, was Harita on the opposition side. And I'm very pleased to say that the judges were very pleased to say that the winner was Elliot Shaw. Now, the winning team, the nose team, they get a little presentation.
Hopefully nothing digital. That's that.
We have more presents. One of those presents is we have to thank our chair for tonight, Professor Lord Robert Mayer, for his work. Thank you very much, Robert.
Thank you.
Thank you.
Thanks very much.
And I believe Sally has some presents to give. Sally?
Thank you, everyone. I hope you enjoyed the debate today. And so to conclude the event, actually, I would like to invite Rachel, the project manager for the Digital Road, up to the stage, and also Nevena, the senior project manager for the Future Roads, and also Amy, the project coordinator. So it is the... So although they haven't spoken as one of the part of the debate team, but they have made this event possible. And they put lots of effort in making this happen, and also their dedication for the programs made it a success. So thank you so much, the team. Thank you so much. And I hope you enjoy the debate and have a good evening. Thank you very much.
Thank you.